Hey guys, welcome back to Quick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Innocent Monkey. It's a medium problem of probability type. You guys can pause and go over the problem. So we've been given a monkey who throws a fair die and he eats as many bananas as are shown on the die. Well, this is the case for when the number is from 1 to 5. But when the die shows 6, something special happens. The monkey will eat 5 bananas like instantly, and then he gets to throw the die again. And whatever comes up, he gets to eat those bananas too. So let's say he throws a 6, and then he throws a 2. So he eats 5 bananas after the first 6, and then 2 more bananas. So that's a total of 7. Now this may continue indefinitely because he could have kept on getting 6s, right, indefinitely, in which case he would just keep on getting 5s. These 5s represent the bananas that he gets. Now, what we've been asked is the expected number of bananas the monkey will eat at the beginning of the game. To map out the probabilities and the expected value, so I'll just call x as a random variable denoting the number of bananas the monkey gets to eat. Now, for 5 of the 6 cases, it's pretty simple, right? For each of those cases, 1 by 6 into 1 plus 2 plus 3 plus 4 plus 5 for these 5 cases. But for the last case, which also has a probability of 1 by 6, what happens is he has 5 bananas, but there's also another value. Now let's talk about what is this value going to be over here. Well, what does this case represent, first of all? This case represents the case where the dice shows a 6, and now he eats 5 bananas, as represented over here, but he's also going to eat the number of bananas that he's going to get now that he gets to throw the dice again, right? So in our formula for E of x, it's basically the summation of probability of capital X being x times x, right? Now the probability was denoted by 1 by 6, and now we're having to talk about the small x, or in this case, the number of bananas that the monkey is going to eat in this case where he gets a 6 on his first try. Well, so basically this 5 is here because we know that he's going to have 5 bananas immediately, but this value over here we still don't know. This, I can say, is basically so this value over here is basically the expected number of bananas the monkey will eat from the second roll onwards. So what's happening here is he got a 6 on his first roll. Now he's going to roll again, and this value, the number of bananas that he's going to eat over here, the expected value of this is basically what we are supposed to put over here. Now, try to think about this. Is this case any different from what we're talking about when we're trying to calculate this value over here? No, this is basically an identical repeat of the initial scenario. The expected number of bananas that the monkey is going to eat, given that he has rolled a 6 on his first roll and now he gets a second roll, he gets a completely new roll, is going to be the exact same. What I'm trying to say is this is going to be E of x only, right? So if I denote E of x as x, basically my equation over here, this one over here, my equation over here, basically this thing, is gonna become x is equal to 1 by 6 of, so I'm just summing all these values, so it becomes 15, plus 1 by 6 of 5 plus x. Now this x and this x are the exact same, and this is the crux of the problem. It is crucial to understand that the pattern repeats, right? The expected number of bananas that the monkey is going to eat at the start of the game before the very first round is the exact same value as the expected number of bananas that the monkey is going to eat, given that he gets a 6 on his first roll, and now we're going to count the expected number of bananas that he's going to be eating from the second roll onwards. It's the exact same scenario because the process completely resets, right? So imagine this was the first roll, this was the second roll, and so on. Since the scenario is completely identical, the value of expected number of bananas going to eat for this entire process is going to be the exact same as the expected number of bananas that he's going to eat from this entire process, right? So that's why the value x can be plugged in both locations. Now, this just becomes a matter of simple algebra, which gives you a value of x equals to 4, which is the answer to this problem. I would highly recommend you guys to pause and read through the official proper mathematical solution. It's the same approach, but over here it's given in a much more formal manner. I hope you guys understood this solution, and thanks for watching.